All right, next up we have from Ally Bank, Amy and Alex, who are going to give you a little reprieve in talking about AI so much. And let's just talk about doing some normal advanced analytics without AI. So, Amy and Alex, come on up. Good luck,
guys. Everyone's headphones on. Can you hear me?
Perfect.
Fantastic. This is a great view from here. Everyone looks fantastic. So thank you so much for joining our session today. We'll be talking about strengthening AML programs with advanced analytics, thinking from a rules engine, from a scenario-based, and beyond. So let me get the clicker, get organized here. So I'm Amy Marva. He mentioned, we are from Ally Bank. I've been at Ally Bank for coming up on 8 years, and manage our analytics and operations team, so doing anything from our transaction monitoring, which we'll talk about today, as well as customer scoring and sanction screening. And I will let my colleague introduce himself.
And I'm Alex Gully. I'm a data scientist at Ally. I've been there for about 7 years now, and I do everything data science, so just in the title. So that's it.
Awesome, great, thank you. So to kick us off, hopefully everyone's in the right place for an AML session, so anti-money laundering. But to make sure that we're all familiar with the topic here, give a little crash course. So our goal overall, when we're talking about transaction monitoring in the AML space, is to stop criminals from moving dirty money through the financial system. So if we think about the path forward for how we execute on that, we need to know who our customer is. Definitely through onboarding, a lot of information is collected, and we do need that. It's absolutely critical to be able to execute our scenario monitoring. Then once they start transacting as customers, we're able to monitor all of their transactional activity through different methods, like transaction monitoring scenarios, which we'll talk more about in a little bit. And then any of those scenarios that identify potentially suspicious activity, or you may think of as an anomaly, a team of investigators would actually review that customer and that activity to determine if it truly is suspicious. If it is, a suspicious activity report will be filed with FinCEN, and that is the main output of what we do from a transaction monitoring perspective. For me, the work that we do is really important and kind of keeps me getting up every day and going to work, because we're able to better protect our customers and the overall financial system by detecting and preventing financing of terrorism, drug trafficking, and things like human exploitation. So as we get into the meat of the presentation today, we'll focus on 3 areas. First, considering moving into an advanced monitoring techniques in a regulated industry. Then, in order to actually do that, definitely need to take some time to influence the leaders around us and business partners to accept machine learning strategies in addition to our rules-based scenarios. And then lastly, I will hand it over to Alex for our last item here to walk us through a practical example that we actually did at Ally to integrate machine learning into our monitoring. So to kick us off here with a pretty big buzzword, modernization. So as we think about that, really it could mean advancing to different types of technology at a technology conference. It could just be integrating something brand new, but also it could mean integrating next level machine learning or models or AI. But at the core, in an industry like financial services, we have to always make sure that we are introducing things that are reliable and to maintain compliance. So as you can see in this graph here, we've got 2 different types of complexity, which is at least the way I think about it. So monitoring complexity, thinking about the actual model you're using or technology, and then oversight complexity. So thinking about things like governance, who needs to be on board in order to keep this moving forward, essentially getting buy-in up front, and then being able to ensure that it maintains compliance over time. Things like machine learning can definitely degrade, so depending on what you're talking about, the right level of oversight is absolutely critical. So if we move away from just the modernization line to a few different types of things that you could be implementing, could be anything from rules-based monitoring, which is definitely the core of what we do in AML for transaction monitoring, all the way up to something like Gen AI. So you can see as you move up to things like Gen AI, increasing complexity on both sides. And what's really unique about where we are today is that a lot of our leaders and regulators as well are encouraging innovation in a lot of areas. So that's really helpful when we're thinking about it from an analytics side. We don't have to really go against the grain there to try and convince them that this is going to be helpful, but they are also expecting very strong delivery that still can keep everything safe. So one of the things that we feel is really important is that while there are so many opportunities, we know that it can be really hard to decide what specifically to do. So that makes prioritization and sequencing critical in your modernization journey. So that brings us to kind of what our journey and that we'll walk through today was, and how we built confidence in that vision. So our goal was to modernize scenario monitoring through controlled enhancements to both expand coverage and improve efficiency. That's really critical as we look into mechanisms to be able to better detect, to enable earlier detection of emerging risks using machine learning, which is really helpful because it's able to identify subtle behavior shifts that traditional rules-based scenarios really is not able to identify. The who in this case is pretty important, so which is also why I have Alex here. It's very important to have your proper staffing, data scientists, whatever it is you're really trying to implement along your journey, identifying what's the core knowledge that you need, and then be able to build that team. Jumping in and wanting to be able to implement whatever is the next best thing is not going to go well without the right people. So thinking about who that is for you is really important, as every institution has a different journey. And then as you build kind of the brains behind the vision, you can really take that to the next level and drive early leadership, audit, and regulator alignment. So that's something that we did. We did not just jump right into a brand new implementation of something that Alex will walk through, as well as some other things that we won't have time to talk through today. But what we've done along year over year is continue to explain to our regulators what it is we want to do, why we want to do it, and that way it doesn't come as a surprise, essentially. So definitely recommend doing that in order to help you be more successful. So now we get to the planning part, which is definitely my favorite. So figuring out how to sequence your roadmap on your modernization journey in controlled steps is really important, and something that we will walk through today. So first, establishing your core monitoring. So in this case, transaction monitoring scenarios, it's really a non-negotiable. So without that, you really cannot maintain your compliance, since it is the core of what we're doing. Then we will move into, in our framework, building explainable models, something that is more interpretable for not only your technical team, your investigators can better understand why this may be coming up as an alert, but also your leaders and regulators alike will be able to better understand it as you're introducing new topics without jumping ahead maybe all the way to AI, thinking about something that's more explainable. And from there, you can begin to scale once you've introduced that. So I will now hand it over to Alex to walk through our framework.
Thank you. So now I'm going to help go through an example of this. Amy did a very good job of kind of setting the concepts that we really care about, but I feel like everybody wants an example, so that's what we're going to do. So just kind of give you an idea of what we do with financial crimes monitoring, kind of give you a background of it so that as we talk through a little bit more about it, you guys can really understand kind of where we are and where we want to go, and then all within this kind of context. And so for us, the big objective for us is to detect unusual transactional behavior. And this happens both in AML and fraud, which we just consider as part of financial crimes in general. And so that's the big thing we're trying to do. And a lot of the ways that we do it in the beginning, at least, from the beginning, has been through rules-based monitoring, which we're going to kind of go through a little bit later. But rules-based monitoring has been basically the foundation of how financial crimes has been done. It's simple to understand, and it really just has been very strong in this industry. And I think just based off of the sheer amount of AML and fraud things you've seen out there, you can tell that SAS definitely is somebody who is really present in this industry and continues to be a leader in this space. So first I want to go through what rules-based monitoring is. So you can think about it as a set or just a condition that we're trying to apply and then differentiate between two different types of sets of people. And so like when you think about it, it's really just drawing a line. Because like, as we look at this graph here, you see this line being drawn, this dotted line. And really, that's what a rule is. It's setting a condition and says anything, in this case, above this line, we're interested in. Anything below this line is something that we may not be interested in looking at. And so as we build these conditions, we basically have to have people doing these. So we have people maintaining them. We have people who have to constantly have to tune the thresholds to make sure that they're appropriate. The other part is that, as you can see, it's a very blunt instrument. So as you just draw a line across, it just basically says everything above. And so our world isn't really that simple. It's a lot more complicated than that. And so while this does a good job of finding a lot of things, it also has an issue where there's a lot of false positives go along with it. And that causes us to have to use a lot of resources in order to appropriately work all the alerts that would be above this line. So you can see there's a couple of red dots up there and some blue diamonds and things like that. And those sort of represent a true and false positive. And just all that area that we're looking at, it's just a lot of effort that it takes both to tune and then also to investigate. So because of those reasons, the maintenance, and then also just how blunt of an instrument it is, our industry has really been looking more towards machine learning as the answer. And it's a great tool, helps increase precision of our monitoring, but there's also some challenges that kind of go along with it. And one of the big challenges with working in the regulated industry is there are expectations that regulators have of us. It could be, or other IRM functions like audit, model risk. All those groups have to basically approve of the things that we're doing. And some of this comes down to whether we're fulfilling all of our regulatory requirements. And so machine learning models, because they tend to have this trade-off where you can get less false positives, but on the other hand, you might introduce false negatives. And one of the hard parts for us is that once we've seen something, we can't really unsee it. You can't be like, well, our model now doesn't see this, so it's totally fine. We actually have to then go through and describe that situation, why we're okay with it. It's a lot of making a risk-based decision, which, especially if you're not used to that, is a little bit uncomfortable for people. The second challenge is that rules-based models are really easy to understand. And so you can think about a threshold being maybe a customer has to have been here for 12 months or so. That's really easy for people to understand and grasp. And so when we talk to our leadership, we talk to regulators, you say that plainly, and it's very clear on its face what that means. And so I think that's really one of the benefits of rules-based monitoring. And it makes it hard to sort of pivot away from it when you start talking about machine learning. Some of the things you describe are a lot more foreign, a little bit more abstract than just simply saying, this person transacts over this amount, so then that's what we're interested in. And then the last part is that machine learning really requires having access to labeled data that is representative, at least if you're doing a classification model for a supervised classification model. And so that's really hard for us to be able to do, since just by definition of what we do, we look for unusual behavior. So all of our labeled transactions, all of our labeled customers, all of our labeled data, all revolves around what we consider to be unusual. So it's very difficult to say, oh, well, we have a representative data set of our customer base when we're looking only at unusual transactional behavior. And so that becomes a challenge. We can't just create a model that's based off of data that's narrow and focused and then expect it to be able to generalize across all of our customers. And so those are the big three challenges that we have. And so based off of that, we also have three objectives that we think help sort of mitigate those a bit and kind of push us in the direction that we'd like to be. And so the first one, and I feel like it's kind of an obvious thing for people, everyone's going to be like, yeah, we get it, but sometimes it's just easier to put it on paper and to talk about it. And the first one is augmenting our current monitoring. And so that helps us stay away from any sort of risky positions, because all we're simply going to do is put some monitoring on top of it. And so as we do that, because we're not affecting our current monitoring, we're just simply setting new things, there's not really going to be any loss of coverage from a regulatory perspective. The second thing is using highly intuitive model. And so if you can find some way to connect it with people, kind of like meeting people where they live, it's a lot easier for people to accept what you're doing and be able to work through and iterate towards more complicated things. But first, you kind of have to establish a nice base of knowledge. And especially as we think about machine learning, a lot of people who are not practitioners, they're going to hear all the terms and concepts and they're really not going to maybe fully grasp it. It's kind of uncomfortable having to make decisions on things you don't fully understand. And so like we think about ourselves as being somewhat educators also, along with doing data science. And some of that is by helping them along the journey similar to how we would. And the last is designing an exploratory model. And so because we have such biased data, what we want to do is be able to explore more of our customer base without having to introduce a lot of false positives. Because again, we still have to think about efficiency. And so when we think about what an exploratory model means, it could mean finding new opportunities, it could be looking more at things that we haven't normally looked at, but being able to prioritize that so that we can effectively use our resources while still getting towards our goal. So what was the project that we decided to use? So we call it SAR Similarity. And so the idea is just basically come up with like kind of a recommender system, you kind of think about it. So like you go shopping online, you buy something, you put it in your cart, and then they say, hey, we noticed you put this in your cart. Maybe you'd like to look at this thing. And that's kind of the same idea, is like we find characteristics about the activity that we see that's suspicious. And we try to match it up with customers that we see that are not alerting. And we basically present that to investigators and say, maybe you might find this one suspicious as well. So what model did we use? So I don't know if there's any practitioners in the room, but what we use is a K nearest neighbor model, or KNN for short. And what this is, it's a supervised model that uses voters to basically say, use a plurality of voters to determine what the predicted class is going to be. And for a lot of us who have actually gone through schooling, things like that for machine learning, it's actually one of the first models we learn. And that's kind of like why we chose it, for one, is because in all of the same ways that we try to go through this journey, we also want to bring all of our stakeholders along the same journey that we have. And it seems like a very proper thing to do because it's very simple and easy to understand, very interpretable. And one of the things that we really like about it is that when we talk about what these voters do and how we determine which voters to include in there, it's really based off of something that we're all familiar with from early geometry, Pythagoras' theorem, a squared plus b squared equals c squared. I'm pretty sure most people will nod their heads and be like, yeah, I remember that. It's kind of like everybody remembers mitochondria is like the powerhouse of the cell. Everybody remembers that as well. And so it's kind of like stuck in everybody's brain. And so what helps with that is that it helps kind of connect people to the concepts we're using here. And so as I described, like distance as a concept, how we measure distance, and you describe that, maybe they're not fully understanding exactly the specific calculations that go into it, or maybe the intuition, like how that works, but they do kind of understand what it is doing and what it means. And that's the important part, is that they understand the meaning behind all the stuff that we do. And so as we think about how K nearest neighbor works, basically there's like these two circles. If we take like K equals 3, and you see that kind of the inner circle. And so there's 3 voters inside of there. And so what you see is 2 red dots and then 1 blue diamond. And so that represents the voters. And so because there's more red circles than blue diamonds, then we would predict it to be a red circle. The other part that we see is we extend it out into 5 nearest neighbors. And then 2 more blue diamonds get added. And then what that means is now it's flipped. And that's sort of an important concept for the exploratory part that we talked about, is that it becomes very locally sensitive to changes. And so if we wanted to build something that's adaptive, it's really helpful if it can also adapt very quickly to new and emerging things, because financial crime is constantly changing. People who work in fraud can very much confirm that as well. AML is not as fast moving, but it still has elements of that. But it's really important for us to be able to have something that's adaptable without requiring people to have to go in and specifically manage that. And so that's what's really nice about it. And then not a lot of adaptive assumptions. So we would use the word non-parametric model, but really what it means is there's not really an expectation of what the data looks like. And so if we have a very biased data and we want to be able to predict on things we have not necessarily investigated, it's helpful if we don't have a lot of data assumptions about that. Really the only assumption that it makes is that based upon the features that we choose, that distance is going to equal similarity. And that's why it's called SAR Similarity. So yeah, that's the model and what we did there. And so kind of as we evaluate the model, we really want to think about, against the goals that we had set for ourselves, what is that, like how do we do with that? And so like the big thing for us is that we wanted to come up again with like an intuitive model, and that helps with our stakeholders. Our stakeholders can understand it. They don't have to worry so much about like understanding the model or feeling comfortable with the model, because we have to worry about all the governance that goes along with it. We have to worry about how do we make decisions with machine learning models. There's a lot of like new concepts that we learn that are different from rules-based monitoring. And so like we want to make sure that we can allow them to concentrate more on those, kind of like the blocking and tackling of just like running a good program, as opposed to having to worry about understanding the model. Because we do think that it's important for them to be able to fully understand what things that we're doing and why we're doing them. The other part is that like whether it's augmenting everything. And so because it's sort of just, it's trying to like explore sort of the edges of the space that we are looking at, that's how we're using it to augment. And the important aspect of it here, this diagram is going to obviously show you, is that we use our rules-based monitoring to drive what we find in SAR similarity. But on the other hand, because what it does is it adapts to new things. As we find emerging patterns in the data, what that helps us do is it helps us find more rules to actually produce. And so what we see is this sort of circular pattern here where the rules-based monitoring will drive what's in SAR similarity, which will drive what is in rules-based monitoring. And this really kind of helps establish like what's useful about AI, or not AI, sorry, about machine learning, and like how we can like integrate it together with our current monitoring. Because I think a lot of people feel like it's sort of a choice between you either do machine learning or you have rules-based monitoring. And really, we really feel very strongly that you have both. There's reasons to have rules-based monitoring. There's reasons to have more machine learning monitoring. So that's kind of the aspect there. But again, also then, because it's also exploring all that at space, it's also very exploratory. And the nice part, again, is it's a systemic way that doesn't require our other teams to have to manage creating new rules, as we find that intelligence through some of our machine learning models. So that's sort of the big thing for us, is just being able to have something that's adaptable, because we only have so many resources to be able to effectively produce these models, and being able to have something that helps us drive those efficiencies is something that's really powerful for us. So that's it.
All right, and to bring it all together for you guys, so Alex talked through the example of SAR similarity and comparing that to transaction monitoring. So this is kind of where we want to hit home that this type of planning is really effective no matter where you begin. So we talked about core monitoring being just rules-based scenarios, building explainable models, SAR similarity, and that now we could scale to advanced models. So at Ally, we have been able to do that. We have additional models that we aren't able to talk through all of them today, but through that process of going through this type of planning, to be honest, like we didn't get too much pushback from leaders, a lot of buy-in. It was a lot easier than the first time when we went through it, and what, as Alex explained, is a more interpretable model, right? But we still had so many questions, and that was a couple years ago for sure, but we've been able to scale and continue moving forward and have multiple models in development. And so what we've seen through our efforts is that once we implemented machine learning for the first time, it kind of then starts to become your new baseline. So not only have you implemented something to expand coverage to your program, but you've also brought all those leaders along, like Alex talked about, and now everyone has this new base understanding that they didn't start with before, and you are naturally going to be more successful in taking it to the next level. We're all here at this conference talking a lot about AI, so it could be that your institution has done this like we have, but if you're further along in your journey, or even if you're not, but if you are, like, you can think about this as the same way as AI. What is your core monitoring? Are you still set in that core monitoring? That absolutely is critical in order to maintain compliance. What have you built to that is now becoming your new baseline? And then how can you integrate AI? And you could have a whole plan that just talks about sequencing your AI implementation, even as we've seen a lot of leaders definitely want to just like jump right into AI, and I definitely think that is valuable to have that conversation. But once again, sequencing is going to help you be successful from the technology and analytics side. So with that, I want to thank you all for your time today, and we have some time for questions.
If you have any questions, just raise your hand. I'll come around to you.
right there.
Hi guys. I guess more for Alex, I kind of had the question when you're talking about the machine learning and everything, and because I assume we're never going to really take the rules-based monitoring obsolete, just because, like you mentioned, it is easier for frontline to understand why things are being stopped. So what would be a sample size that, is there any sort of sample size, or is it just a randomized if there's a spike in a certain type of trend going on that where it then learns to alter that rule?
So the nice part about K-Neighbors Neighbor model is that once we drop in like a new alert that is like ends up as a SAR, it immediately starts scoring that. Because what we and that's like kind of the nice part about it is that because it just immediately will react to it, then they can start exploring that portion around it. And if they find that that's an isolated event, then it's basically a non-starter. It basically dies at that point. But once we start seeing pockets of those things happen, that's when it starts to become more of a thing like, oh, well, maybe there's something to this. And then we have to go and look at the characteristics that are present in all of them, or at least in some of them, and look for those patterns and see whether or not it aligns to some sort of typology we already have, or potentially a new one.
Hi, great presentation. The question I had is, how do you balance maximizing the utility of machine learning in conjunction with building like explainable models? Because I'm assuming you have to deal with regulators with AML, right? So how do you get the balance of those two, maximizing effectiveness but also interpretability?
Go ahead.
See that?
Go ahead.
Okay. So, I mean, I think it's very difficult, obviously, to like figure out what the right balance is, and a lot of it is trying to work with your external stakeholders to try to understand where that risk appetite is, and that's like what a lot of it comes down to is what people are comfortable in terms of like how interpretable it's going to be. Because I think there is basically this journey, as like Amy had kind of shown in one of those graphs of like we're going to become less interpretable as we go further and further to the right, and so it's really about trying to make sure that people are being brought along the journey and that you take those steps, those intermediate steps, to make sure that they're starting to understand there's more and more things that they're probably not going to fully understand, and getting them comfortable with that. And so starting with the interpretable models is really important, but where we end up, especially as you think about all the other sessions around generative AI, how many people are going to understand that? Probably not that many. And so it's really about making sure that there's governance, there's like an understanding of how we make decisions on that, not so much about whether they're going to understand the models at the end state.
And I would add to that, I think just making sure that you're able to evidence that it is adding to your program and just like increasing effectiveness. I think we've got really positive feedback from that sense where regardless of what we're trying to add, it's as long as we're able to evidence it, document it along the way. I think that's kind of what you're talking about, like bringing those stakeholders along. If you can do that, then I think that's definitely laying the groundwork for yourself as you go into the conversations with regulators, for example.
I think like the question that we get often is, how do we know this is right? And that's like the key part of answering that. How do you know that it's right? And that really comes down to like doing performance monitoring. So I think that's a big piece of it as well.
Awesome.
Any other questions? We got one.
As you started to implement the machine learning models and then that influenced your rules that you were building, were you able to determine how the false positives decreased over time? Were you able to develop metrics related to that to help with your argument with senior leadership on continued investment?
Yeah, I think, and you can correct me if I'm wrong here, I think the thing that helped us do is be able to specifically target things, which helps drive down like the false positive rate as per some of our other scenarios, which might be a little bit more broad. And so because they are very specific, they just happen to be have a lot less false positives.
I think then too, thinking about how this can inform what we do next. So spending time learning about which features are effective, what has led to, in this case, effectiveness for this SAR similarity model, meaning finding true positives that may have not been identified through transaction monitoring. We can then take what we've learned from the technical side and say, okay, what else can we do for like anomaly detection? And then we're talking about, kind of to your question too, about is there another way to augment transaction monitoring, and I do think that there's a strong potential that could help reduce false positives, depending on what the typology is, type of behavior. It's very possible that anomaly detection is going to perform better. But I think this strategy of going through the process is really worth it, so that you can evidence before you ever say, I want to replace it, you can prove it to really lay your own groundwork for your success. So.